ahead and not a problem here. I want to go ahead and say good hi to everybody out there. My name is SBowman. I'm the Vice President of Engineering here at Tomahawk Robotics. And pleasure to be able to talk to you guys today. I think we got some cool stuff that we've been working on down here in Melbourne, Florida, not too far down the road. My background, I'm an electrical engineer, bachelor's degree. I have a mechanical engineering master's degree in controls. After I graduated from UF, I ended up over at L3 Harris for about 11 years or so, working in embedded software and in controls realm with manipulators and ground robots, and designed some of those over there. And then left Harris to start a business with some of the guys I worked with, Tomahawk Robotics, and here we are. We got a little over 40 people in the company now. We've been in business for about 4 years. At this point, pretty much 100% defense and defense applications. Today I'm going to talk to you about our kind of universal AI-enabled robotic control architecture called Kinesis, and some of the hardware elements we make, to complement that software package. So I'm going to go ahead and
Scott, before you begin, let me just set the stage for everybody.
Sure.
So just so everybody's aware, we are recording, and a copy of this recording will be made available for those who are unable to attend. So for the format of tonight's meeting, we're going to start with our guest, Mr. SBowman, providing a presentation concerning his organization's development and integration of uncrewed and robotics technology. After, I'm going to lead you through a series of introductory questions. Then we're going to open it up to class-wide Q&A. I do ask that you all mute your mics, save all your questions to the end, and that you use the hand raise icon to indicate when you do have a question, so I can call on you in order. I also want to note that I'm going to be capturing and sharing online links to important concepts, details, and tools that are brought up in our discussion tonight, and you're going to be able to find those in the video notes or in the discussion area tomorrow. So with that, I am thrilled to welcome you to the 13th session of our UNSY guest subject matter expert speaker series. Tonight we have our guest SME, Mr. SBowman. As he was giving you some background on, he's a multifaceted engineer with over a decade of experience in design, building, and testing electromechanical subsystems, especially in the area of aerial and ground robotics. And with that, I'm going to turn the stage over to Scott.
All right, appreciate the intro there, Brent. I'm going to go ahead and I'm going to kill my video here now that everybody's seen me to save some bandwidth. All right. Here we go. And again, Brent, appreciate the introduction. I will say, I think I have, I don't know, maybe I'm up to like 22 or 23 patents at this point. I've done a ton in the areas, like you said, in ground and air robotics, in miniaturization of electronics and autopilot systems and manipulation control. So, my background is very broad, but all that I think is important to bring up, why Tomahawk's so unique and some of the stuff we're doing and the way our view of the world as far as, robotic control goes. So with that stage set here, next slide, see if this is going to cooperate. All right, so good. Everybody see that? See the slide transition?
Yep.
Okay, all right. So, Tomahawk Robotics, like I mentioned, we're down here in Melbourne, Florida. Majority of the founders were, all kind of work together at L3 Harris doing robotics applications. Started with 3, we're up to about a little over 43 employees, 22 of which are engineers. And our mission, and you'll see our, the kind of the problem set here in a second, is to build, software and enabling technologies that make, unmanned systems more effective, easier to use, and safe to employ in tactical environments. In general, we have over 100 years of experience, probably over 200 probably at this point, over the last couple of months, getting a lot of great employees and stuff. But just a ton of experience in this area, which really drove, as you'll see, development in software from a common operating picture to uniquely qualified hardware to run the software to make, again, to really achieve our mission statement. So here's the problem, we're trying to solve, why we wanted to go about this on our own here is, today in defense, the systems of the last, 10 years have basically been, or maybe more at this point, have basically been purchased on what they call a UNSY, which is basically like a quick react need for capabilities. And the capability sets are very siloed. So you'll have, the large robot there with 8 wheels is, its capabilities to just carry some stuff behind the soldier or what have you. Maybe the next one is just for reconnaissance, and the middle one as well. The other one is maybe for handling. The fourth one there is for handling, IEDs and explosive devices. And the one on the fixed wing aircraft there, the Puma, is mainly for long range reconnaissance and stuff like that. But each of these are operated with different controllers, and this is just a mix and match. These aren't exactly the controllers that each of these use, but gives you a sense of hey, how bespoke each of these controllers are for and disconnected each of these controllers are for each of these platform types. And today these are bought, that controller for that vehicle for that capability, that controller for that vehicle for that capability, so on and so forth. And the problem really is that statement across the top there, where the way we engage in combat, future forces wants to have more lethality using unmanned systems within the dismounted unit, right? Which means it's a foot soldier carrying capability in on his back, and he wants to be as effective and efficient as possible operating that equipment. And so the Tomahawk solution is one application with a single application that controls all the vehicles the same way within the single app. Some of the issues that arose in that we're seeing now in defense, on the bespoke procurement method is, of course, size, weight, and power. There's just too much hardware to carry for the dismounted soldier. Most rucksacks that these guys are carrying, especially in the Army, are between 90 and 120 pounds, which causes issues with knees and lower backs and stuff later in life. They're certainly much more expensive because there's more hardware, more training, more maintenance of all these different pieces of hardware. And they're just it's inefficient to execute because oftentimes one or two people have to know the skill sets to operate all these different kinds of vehicles, and remembering how to do that for just the hardware alone is difficult, not to mention all the different software packages that are on these and all the different elements that go with that. Whereas our the Tomahawk solution, it pulls everything down to one controller. It is less expensive because it has less hardware, and the big cost savings that we're really seeing these days is a common operating picture, so therefore common training. So when the user is used to going down and selecting a vehicle, they're going to go down to the lower right. There's the vehicle list. That's where they're going to go and select a vehicle every time, no matter what. Left on the stick makes every vehicle roll left or turn left or what have you. Which then makes them more efficient in their execution, kind of the last bullet there, and more lethal because they can do things much faster and create that muscle memory. So in stressful situations, they just know, their body just knows what to do. I guess that's probably everything on this side here. Let me do the next one. Okay. So some of the things we're going to cover today is basically how we're going to achieve that overall operating picture and some of the other hardware elements and software elements we have kind of in our architecture to achieve that all-in-one operating picture, as well as be able to bring in some AI and machine vision, machine learning type capabilities on the loop, if you will, between the operator and the vehicle in this kind of common architecture. So as I kind of mentioned before, all of this is achieved really with one single control app called Kinesis. And that, this app is, basically allows for, the solution of battle space networking, right? And this is the biggest problem that we found as we start to, look at controlling different vehicles, all simultaneously. I guess that's one thing I didn't mention a couple slides ago is not only do we have a single controller with a single piece of software, but we're also able now to bring all those pieces of all those different robotic platforms in different domains, air and ground, or sea, all into, one common operating picture on one common network. So, the networking piece was probably one of the bigger pieces we had to kind of solve to allow that to talk to each other. And then, then this Kinesis software allows us to go and, go and talk to different, protocols that the different manufacturers use to actually, control their vehicles, and then turn that into this common operating picture, which, I have some slides coming up to give you a flavor of kind of what that looks like. Very kind of modern, mobile device, kind of design patterns, very user-centric, maybe no more than, 2 clicks or two taps to get to something. And, just very streamlined for the operator, and I will add, today, operators already have to have, and the reason we chose a mobile device is because, today they already have to have this mobile device, on their chest, basically, to be able to see, in with respect to the rest of their team or squad, where they are and where everybody else may be at a platoon or company level, where everybody else is, to kind of situate themselves and have good situational awareness. So they were already wearing that device. It made sense for us to go ahead and integrate everything onto a mobile device. Mobile devices today have very good, good processing, good graphics and good multimedia capabilities. So, we thought that'd be the right device, again, allowing the soldier to not have to carry any more equipment than they really actually need. They also, kind of that last bullet there, and the key benefits of Kinesis software is it's able to go and share, where the operator is and where a lot of the vehicles are that we've integrated out to another piece of software that all those other team members that already have those phones on their chest are wearing, called ATAC, which is Android Tactical Assault Kit, which is basically just a mapping software, again, to kind of see where everybody is. But we interoperate with that to allow people to see where all these different, vehicles are, to give some idea of, assets on the battlefield. So, here's kind of a dichotomy of how it works. And there's, one piece of the architecture and the hardware architecture, and there's some more coming up here that you'll see. But basically, there's a device there called KXM, which stands for Kinesis Expansion Module. This is basically an edge compute device. So we have a partnership with NVIDIA, and we have a Xavier NX processor that runs in this piece of hardware that we've designed, that basically allows connectivity of different radios that would talk to these different platforms. And KXM is achieving all that networking I talked about earlier to go and talk to our Kinesis software that's running, on that common controller that you see at the top, and then pushing down COT data, which is cursor on target, which is those positions and video feeds from all these different platforms over that tactical network onto the software I mentioned called ATAC. And so this gives us our kind of primary operating view, and really does all that, the heavy lift for all that, the networking stuff I mentioned earlier. But in addition to that, because it is essentially a computer, and a very high power computer and a very small form factor, it gives us the ability to, because of a lot of the hardware acceleration and GPU capabilities of this processor, ability to add aided target recognition through semantic segmentation and different AI techniques for classification of different assets and stuff in the real-time video coming from all these devices. You'll see we're able to host some training and simulation. I have a slide in that coming up. This also allows for enhanced autonomy capabilities, right? All these devices are networked together. They know where everything is. They know dynamic capabilities of each platform, how high this could fly, how fast that could go. What are the grade, the SMET, for instance, in this, how high it can go. And now you can start to kind of cluster that network of capabilities together to achieve, leader follower capabilities or automatic overwatch capabilities, things like that. Indications and warnings, we're able to kind of monitor all of the different interconnected systems for, predictive maintenance kind of things, or even, real-time, errors and warnings, what have you. And then, mission planning, kind of goes back to that, in part training and simulation, being able to kind of game out how you're going to achieve or attack some kind of, position, and then being able to go and, either within a digital twin and simulation environment, game out how that's going to go, or just, purely on a 2D map, putting, waypoints down and assigning these different assets or different vehicles to go and, to go and run that kind of CAM mission. Okay, what's on here? So here's kind of lays out, a tactical use case that our customers today, very much are doing. And this is really really just highlights the disbursement of different troops and different elements of a company or squad or what have you, where they're in different positions, and a user may need an overwatch capability, so they'll go and take control of the SRR, so that's a short range reconnaissance drone from Skydio that can sit, for instance, in the middle of an urban area, and then provide and look to take the camera and look straight down and provide this kind of overwatch capability of all maybe vehicles that are coming on the different streets looking for stuff. And then let's say somebody gets out of a vehicle and starts to head off one way, and then another user on the squad, because again all of the users and all the vehicles are all networked together, they could take this small drone and go out and go follow that particular person, being very covert about where this drone is versus the person. And then maybe that person goes and sets a suspicious device down next to a door. Maybe it's a bomb or something like that. Then a third operator on the network could go take the CRISI robot, which is a small EOD robot, and go drive out and investigate that. And then the SMET off to the side there, maybe they need some other, maybe they get into a firefight or something like that. They need some other supplies. Any number of these guys in the squad could call in that SMET that may have resupply capabilities with water or what have you, and bring that into the operating scenario, and then those team members are able to go and offload stuff. So this is and off to the right there you could kind of see a depiction of being able to share some of that data from one of these user devices across ATAC, which is both being able to be viewed across the team here, or kind of up echelon to like a command center or something like that. They can get an idea of what's going on in this scenario. So there's n number of different scenarios that you kind of arrange with our architecture, but this is probably a more complicated one as things are getting run today. But I think is a very good scenario of what's achievable across this common network with that one piece of hardware, one piece of software from a control standpoint. Moving on here. So this is kind of an idea of what the user interface looks like. Again, very mobile, mobilely minded, trying to declutter the screen. We've certainly seen a lot of user interfaces that have just a lot going on, kind of information overload. Most of our customers view any one of these assets as really, a sensor in the field, or a sensor downrange. So it doesn't really, at the time they go execute their mission, everything's kind of set up, and if there are these kind of advanced settings, all that's done kind of ahead of time. And then when they're operating, they just want to be very, very slick down, very decluttered as far as being able to get the most important information right there in their face. You can kind of see conversely the ATAC environment down there in the right hand side. You can see there's a little bit more going on, a lot more stuff overlaid on the screen, a lot more kind of clutter, there's just and as you get to clicking through there, you see there's just become kind of information overload as you start going through some of these menus. So on our side, on the Kinesis side, we're trying to keep things very basic. As far as some of the features that we provide within our UI, there's in the upper left there, kind of a hamburger menu for system setup and configuration and such. You can enter a full screen mode that allows you to kind of hide everything on the screen except for the the actual live feed. A mission planner, and you can kind of see in the upper right there when you enter that view what that mission planner looks like. You can set waypoints, different like speeds and altitudes of different waypoints, loiter positions and stuff like that. And again, this interface looks the same whether you're flying a micro drone, class 1, class 2, class 3 drone, or whether it's a fixed wing aircraft or what have you, or even a ground robot. All this remains and looks the same. Mission module, kind of moving back over here on the left. Our mission modules, every modality and every platform has something that is different, right? The whole idea here is that, in the business space, right, all of these different manufacturers are making, they have some discriminator that they want to make sure it gets into their platform so it's better than their competition, so they can get that capability or that platform sold. And so we don't want to lose that, right? So let's say 75 to 80% of what we integrate in a common way is indeed common, and therefore we can achieve that behind our software. But there are that last 20% that we don't want to lose as to give up the discriminator of a particular vendor's capabilities. That would get kind of implemented behind what we're calling mission modules, and that would allow for these additional capabilities, or potentially third parties to write new capabilities, or some canned routine search function, what have you, that gets kind of implemented behind that. So we do have this an SDK, several SDKs actually that are connected within our architecture that allow third parties to come in and add different new capabilities. So us as Tomahawk don't have to try to kill ourselves, so to speak, to go and try to integrate all these platforms. Instead, we put our attention and focus on a software development kit, an API system that people can come in behind and hook up that way, so we can grow the amount of platforms that we're integrated with without having to spend a bunch of Tomahawk time. So a little off topic there, but I'll get back to the UI. We have actions, and these are take off, sit, land, stand, these kinds of things that are inherent platform-centric capabilities that will kind of be there no matter what, and part of that kind of 80% commonality solution. The lower left there kind of shows this is if there's any user options or configuration of the phone or what have you, this is where this would be. You can see those are Greek coordinates. I mean, basically that's a military grid system. You could think of it like lat long and traditional GPS, same thing. Off to the right there, that's kind of your what vehicle you have selected. So if you were to go and press that bar, if multiple vehicles were on your network, you could go and see hey, which ones are there and able to be selected. Actually, I didn't. There was a slide earlier that had a video. They never played over these, over these systems. So if your students wanted to go out into like YouTube or something, you could certainly, search for Tomahawk Robotics. And we've released several videos and stuff. You get a better idea of kind of what this looks like when you interact with it. There's a play. You can see a play button there, and really what that does is, like, if you assigned one of our vehicles a mission plan, that kind of plays and pauses the vehicle throughout that mission plan. And then the stuff off to the right there is for recording the screen, so everything you see on the screen, and then taking still images. And then that the little kind of element up there on the right allows you to create a picture-in-picture mode. You can see in the upper right-hand part of the slide here what that kind of looks like. You can do a side-by-side of a map and a picture. You could do a full screen video, or you could do two simultaneous side-by-side videos of two different robots on the network. Right. Next slide here. So this is, I mentioned before, simulation, because it is, one of the challenges that that's faced today with the military. I mean, or in other sectors of in other markets as well, is just finding time to go out and the right weather conditions to go test things, as well as in defense, just like getting airspace and airtime within certain test facilities is difficult. And so since we already have this on-body compute with that NVIDIA processor I talked about earlier within the KXM, the users can go and run. It's powerful enough to go run the simulation environment that we've created using Unreal Engine, Epic's Unreal Engine, to go and basically allow them to practice using these different kinds of platforms, both air and ground platforms. It gets them reps at using and clicking around through the user interface and getting acquainted with that. And then and we're getting to a point where we're starting to kind of write mission profiles for like actual training. So if somebody were to go and get kind of sold off on our system, they would be able to go and do this kind of mission, this training module in which they achieve these certain goals, and then they could get things checked off as they achieve them, so they could show their superiors that they've gotten trained. And we found that just spending even an hour in here and clicking around doing that directly translate to an operator going and be able to do this in the real world. So, very fascinating, very an interesting human factor study that we've been engaged with several of our customers that, is getting great feedback on this. And again, because it's on body, they don't even have to go ask for permission. They could just literally run the same app that they had to use to control the real robots, and then just fire up the simulation that's already on them on their battle vest, and go into this environment. All right, moving on here. So this is kind of an overview of our product portfolio, and these are a couple of other elements I mentioned earlier that that I kind of left out, that we use to kind of round out the suite of capabilities to achieve that one common operating, this one common hardware and software system that operates all these different kinds of robots. First being our grip controller that we made. It's very much like, it's mapped like an Xbox controller, kind of ABXY, 2 joysticks. The shape of it is very intentional to allow the user, when they hold this thing, to be able to put their thumbs up there and not occlude the screen. So that's kind of why they're up and wrapped around like that. There's, what you don't see in this picture, there's some 2 bumpers on either side, 2 buttons that we provide there. Open architecture interfaces, USB-C to charge it. The phone actually powers the buttons and everything, a little microcontroller that's in there that powers and runs everything in the controller. And then there's a cable that kind of comes out the side that then allows you to connect into tactical hubs and other external devices such as radios and what have you, to be able to kind of to go and control the vehicles. That's one of the controllers we have. We also have what we call Mimic there, that next controller. That is, you could pretty much think of that as a tactical Wiimote, and that provides operators the ability to control systems with one hand, so they have an additional hand free. This is typically used for very basic movements or just control of the gimbal. The way we've kind of architected our software, different users on the network can actually take control of different pieces of the unmanned system. So for instance, if you have a drone, one user could be flying the drone and the other user could be operating just the gimbal on the drone simultaneously. And one of the guys' tasks is to look around and be looking for stuff in real time. So he may only need a Mimic to just kind of go and wand around, if you will, the camera, to be able to kind of look around. So this would provide an even lower weight, lower cost solution for something like that. We have our own series of radios that we make for different applications. We integrate with other radios. There's a handful of common, between a Harris radio or a Persistent Systems radio or others, DJI, what have you. We integrate with a lot of others as well, but we do have some that we make to kind of round out this hardware suite to make that that common operating hardware picture realized. And then the KXM, we make them in 2 different variants. One that has more ports, more capability. One that's a little bit less, it's less expensive and has fewer ports and such. Kind of off to the side, right now, I think we're kind of a little bit of a guinea pig in the defense market as far as where our software is sold kind of SaaS, so software as a service. So if you need more capabilities, and you pay more money, and so it's very different for defense. But at first we were getting some pushback, but now we're starting to make pretty good inroads with that, because the reality is somebody might not need all the capabilities of the highest level software, and they don't just have to buy it for super expensive, and we don't have to and they don't have to just kind of be locked into that for some time. We charge yearly, and we continually do updates that somebody that has a subscription to that is able to go and get these newer updates. And like I said, at first that was government was very standoffish to that, but we've made a lot of inroads here over the last 9 months to a year, as far as people getting kind of warmed up to that. And in fact, it started to really favor it over traditional, just kind of enterprise license type procurements. All of our stuff we do is non-ITAR, so there's no export issues here. We do all our business today is U.S. government in Five Eyes, so Australia, UK, those kind. We haven't done any business outside of that, but we haven't really needed to. We've been demand signal's been very high with what we've been up to. But on here, so I mentioned before, the kind of topic of this of this slide package here is AI enabled common control. And and really what, how that's achieved is with this KXM, right? The KXM, as we saw earlier, it kind of sits in the middle of all these data streams that are coming in from all these different robots. And, we've created an architecture on the KXM that utilizes Docker's, a Docker container to go and run these different, capabilities that, frankly, we don't make. We partner with other companies and say, hey, here is an API call that you guys can, using the Kinesis API that you see there. Here is an API call to, still images that you can bring into your classifier, or your, AI capability, go and, run your algorithm on it and then just give us the results in a common way. And then we can actually take all of those results and put them all together and onto one image that then we spit back out to the user. And of course, we chain those images together to create, full motion video. So then, the result to the user is, the ability to see multiple outputs from multiple different kinds of tracking algorithms. So you may have one that's a company that's really good at finding tanks, another one that's really good at finding trees, and another one that's really good at finding cars. And you could put all three of those together operating simultaneously to give you a resultant of, 3 different hitboxes on 3 different things with 3 different companies that spent their time training those different, neural nets or what have you. So, we've set up this architecture to allow the expansion of these other capabilities that, we don't, as Tomahawk, don't have time or funding or resources to do, but we're able to, allow those capabilities to come in, which has really been an interesting thing to see, because, a lot of these companies that they're doing and creating all these great algorithms, but they haven't really thought through how they're going to actually deploy it and get it out there to feel how somebody actually going to buy that. Well, we kind of have basically like an app store type feel here, where our customers say, hey, I need this kind of algorithms. Hey, we're able to offer you that with one of our partners here. This is how much it's going to cost. And then we, provide a software package that you load on through Docker, and away they go. All of these ports in KXM are USB based. You can kind of see the block diagram there. And again, this allows for connectivity of peripherals such as radios, on-body cameras, and SASM GPSs and these kinds of things to bring all that that data into this network environment. All right. Let's see. Moving on here. This is just a view. Gives you a little bit better true hardware perspective of what these kinds ways that our customers are connecting all this together to achieve different configurations depending on what they're trying to do. And that that conformal battery is basically is a battery, a specialized battery that basically fits in the battle vest of a dismounted soldier, and that would run the KXM. And then from there, KXM distributes power to the different types of radios and and controller, in this case grip, that one that we make. And so these are just different types of arrangements, because our system is very modular and kind of plug and play, that customers can go and plug these different things in depending upon who they're trying to talk to or what vehicle they're trying to talk to. And then using our software on any one of these devices, they could go and achieve that. The last one there, you could see I mentioned Mimic. There's a great example of, hey, the operator is using Mimic and just a phone in a basically a hard ruggedized case without the joysticks and thumbsticks, but just in a very kind of size, weight, and power optimized view of the world. So see the next slide here. This is just kind of more of what we saw before. This gives you a good idea of kind of what the grip looks like on this would be his picture on the front of the user's vest. Is kind of his battle vest, where this kind of hooks into a system called Male. That's just like a strapping system that you could slide in prongs to, basically, and this is what it would look like on his chest. There's a good example of one of the vehicles we integrate with teal, gold, and eagle there above, and then the elements of the system that would be interconnected and kind of worn on body. I also have some pictures of if our customers want to go develop their own software, or they need to connect with just generic devices. We also sell cables and stuff that would plug into KXM to allow this kind of very generic USB-A, USB-C interconnectivity within our system. It doesn't have to use the the military standard connectors that you see in this picture off to the left there. And then, you know, as part of our, you know, our offering and our software suite, this is something we try to keep aligned with our customers. You know, this is a view of, you know, some of the different robots that we've integrated with and the timeline by which that they could expect some of these different platforms to be coming online. And, you know, we have a tiered system, which really just whittles down into different capabilities, you know, what things you can do with the platforms, and where we are as far as integrating those capabilities throughout our, you know, our architecture. You know, some of the, and, you know, the difficult part of, or, you know, the challenging part, I guess, of you know, the speed and the agility of our business is, you know, we'll have, you know, customers that'll come and say, hey, you know, the XYZ vehicle, I see you have that on your roadmap, and I'm not going to get that capability until, you know, beginning of next year. But hey, I have money now. We need this now. We have some operational needs. We want to pay you to move that in, and then, you know, I gotta kind of readjust my whole, you know, my whole development plan to account for that and move things out in time. So there's, you know, we're very agile and Scrum based as far as our software development and trying to react to, you know, customers' needs and stuff, and trying to streamline our automated test processes to be able to support this, you know, this agile approach and guarantee that these systems will all continue to work together as we, you know, upgrade and add more capabilities to them. But today, I mean, I think in different pieces, you know, we've touched about 20 different, a little over 20 different unmanned systems, from fixed wing to rotorcraft, you know, to quadrupeds that you see there. You know, we have a partnership with Boston Dynamics. We've integrated their Spot robot. It's actually much further along. Actually, it's a great example. This chart's actually out of date. We have probably, you know, level 2 type integration with that robot already. You know, for a UK customer, and, you know, some of the ground track robots there, you know, doing a lot with those as well. And, you know, this picture, you know, frankly, every month looks different, but as of a couple months ago, this is kind of what it looked like. And I think, Brent, that's kind of all I had. I know I said a ton. So, you know, I guess I'll turn it back over to you to take it from here.
Outstanding. Thank you so much, Scott. That was amazing. One of the things that I know, consistency is absolutely important to support utility and really wide scale adoption. And you've created a very impressive product that helps to establish uniformity across operational domains. This is, to me, you know, my experience, that's somewhat new and novel, where you see a operational UI that
Right.
can support ground and air, and I assume at some point in the future, maritime might even be on your list.
Yeah, it very much in the works.
Outstanding. You know, exposure to this type of design set, this is one of the reasons that I put these sessions together. It can help our students to further understand functional capabilities, which hopefully then translates into them being able to brainstorm new uses of unmanned or uncrewed robotic systems. In regards to advanced robotics and uncrewed technologies, what are some of the most recent technological advances or breakthroughs that you personally find exciting, and why?
Yeah, a great question. You know, I would say affordable, power efficient, power savvy, you know, GPU capabilities. You know, in particular, you know, stuff, hardware produced by, you know, Coral AI or NVIDIA, with those processors. I think that is really where, you know, being able to host, you know, operationally, you know, host, AI capabilities at the edge, you know, and I would say, in my case, I know the edge is defined in so many different ways for different use cases, but, you know, on Soldier here is a huge breakthrough, I think, in this realm, because of the massive amounts of data that processor that can handle for, you know, 15 watts of power. And, you know, what that allows us to do in our scenario, and I glossed over a ton of this stuff, so I certainly invite your students to go and check out our website and look at some, you know, stuff on YouTube and such, is being able to take in the video, jump in the middle of it, and then be able to go and re-encode that video into also a common format. So, your different unmanned systems, I'm sure a lot of your students are aware, have different video codecs, video compression techniques, or what have you for this, again, their bespoke application. But then those video sets may not be compatible with, different, interconnected pieces of kit today that soldiers have. And so we're able to get in the middle there with that KXM device and get all that great hardware processing that's now available, and go and re-encode that video in near real time. And I'm talking 20, 30 milliseconds of latency kind of, near real time, and turn that back around into a video format that not only is compatible with everything in the battlefield, but also I can now compress it even more so than its original feed, so that we can stay within the bounds of, tactical communications that once was not possible. And just one of these vehicles trying to push video out would crush the network, not allow soldiers to talk, and cause all kinds of problems. So like that is one of the bigger, that and then gives the ability to host that simulation I talked about, that edge compute technology that's out there now, and now allows us to host like a very, near, game type quality graphics in that small 15 watt package that the users can practice with.
Excellent. Well, that actually just, I think, answered my next question, which is the pressing technological problem that you're seeing. I'll ask one last question, and then I'm going to turn it over. I see I've already got some students with their hands up. So if anybody else has a question, start queuing it up now. So Scott, what tools or resources do you personally use to stay informed? There's an awful lot of different venues and
right.
a lot of information coming out constantly. But
right.
what do you use to stay on top of all the most recent developments, and how do you sift through all the available?
No, it's a great question. I think, and I know that Brent yourself is involved with AUSI. That's certainly a great place to start. Us being in defense, some of the other larger shows we're certainly affiliated with, going out there and just getting boots on the ground at some of these different trade shows is one of the major ways we do it. Because then I also, not only do I get to, there's a lot of stuff out there, right? You could read about, you Google around and see on the internet. A lot of it is vaporware, and frankly, what we're doing is, we're a business doing robots, and a lot of investors would cringe at that, because a lot of, the stuff that's being done in robots today is very much researchy, humanoid robots and just super advanced, AI type applications that just, don't have real legs yet and can't be operationalized. Is not the realm that we're playing in. We're playing in very much, trusted robotics and, in the art of the possible today. So, for me, it is very much getting out there and seeing the technology for myself, and realizing that it's not vaporware. It is real. So then we could try to bring that capability into our system. And then the other part of it is just, reaching out and talking to the OEMs themselves, because, we've got great relationships with any of those vendors that you saw up there. And so a lot of the time, we're able to share, once we get to a certain trust level, are able to share our roadmap with them and theirs with ours. So we know what these vendors are thinking and kind of what's coming online, because of those business relationships, as well. I get defense news newsletters. I'm signed up to several of the different, defense news type outlets that I can kind of see, a subfilter of, robotics technologies and stuff that are coming along that I read once a month to try to kind of stay up with things. And then our users, right? Like a lot of times our customers are one of the best ways too. They'll tell us about different, technologies that they've seen, that they've put their hands on, or they're funding through other outlets that, hey, maybe there's a marriage there of technology. So that's, yet another outlet.
Great. And I've got a couple of those links I've grabbed here to share with the class. With that, I'm going to turn it over. First, we have Shelly. If you want to unmute and go ahead and ask your question. All right, Shelly, seems like you might be having some mic problems. You're still muted. If you want to ask it over in the chat, I can read it out. All right,
Hello?
we'll come. Oh, there we go.
Hey,
There we go.
sorry, it kicked me out of the meeting when I tried to unmute. Yeah, thank you for your presentation. I'm an ATAC user myself, so this is very interesting to me. And we're starting to develop sort of a UAS program in my at my unit. So this is all an interesting program and useful. And I had a question about
Sure.
like the interoperability. Like if I had two ATACs that were both Link 16 capable and were speaking, could I, like, say an air ATAC user pull a video feed from a ground ATAC user?
Yeah, definitely. You know, and how we would achieve and have achieved that is, you know, like a Link 16 radio and let's say like a trellisware radio that's used on the ground are both plugged into KXM, and then we can, you know, through some advanced networking things on the KXM, you know, get those, you know, those networks essentially bridged to allow, you know, that TAC data to flow over either, you know, either radio, you know, either comm channel. So
Wow, and could a user have control of, like, say the gimbal, like you were saying, through Link 16?
yeah, I mean, certainly. So Link 16, I'm trying to think of its bandwidth off the top of my head. I mean, certainly control of the gimbal, yes. You know, how great the video is going to be over Link 16, obviously is gonna depend on, you know, comms and everything. Even I think great comms with Link 16, it's got maybe a megabit or so.
Yeah, there's going to be latency as well, I'm
Yeah,
sure.
there's latency and everything else, but obviously that's good for certain things and not for others. But yeah, I mean, we actually had a big demo last week. I was in up at customer site where we had Prick 163s, which are somewhat limited, especially for multicast traffic. We had trellisware radios that were, you know, talking to those. And we had some Silvus radios that were talking to some vehicles and other like TAC users on a different cluster altogether. And, you know, with KXM in the middle there and all the video stuff and all the data coming through there, we're able to carve up different throughputs for the different radio networks. So guys on Silvus radios got much better looking video than guys using Prick 163s that were back at command. But, you know, we're able to push that video out to all the different comm channels and tune it based on the capability of the comm system itself.
Wow, that's really neat, and I see how that could be useful. Yep, thank you for that. Answers my question.
Sure.
Excellent. Dwight?
Yeah, you got me. Hello, you got me?
Yep, we got you.
Yep.
Okay, sounds good. So very impressive presentation. Thanks for coming. Thanks for doing that. I'm approaching the unmanned world from the MUAS platform. That's kind of where my knowledge base is based. And have you ever tried to integrate this with an MUAS such as a Scan Eagle or a Jump, something of a large size like that, where you're having to monitor? Now you're watching, you know, cylinder head temperatures and whatnot versus just an electronic UAS?
That's a great question. You know, and we have not done anything in the combustion engine space. You know, we're kind of, because our focus has been very, you know, dismount first
Right.
and organic capabilities. You know, we do, you know, support a lot of, you know, kind of tier one operators and stuff like that. You know, they carry everything in. So that is, I will tell you though, we are moving up that food chain. You know, we have done some integration. We have a great relationship with AeroVironment. We've integrated the Raven in Puma now. You know, Puma is starting to, you know, certainly not as big as Gray Eagle or Scan Eagle or anything like that, but you know, it's starting to get up to that kind of company level asset that we are, you know, that we've done integrations with and can control, you know, both gimbal and the flight characteristics of that platform. So we are, you know, moving up that capability, and I could see, you know, we are starting to get requests. I'm trying to think. There's a Lockheed Stalker, the Lockheed platform, where, you know, a guy like this, like you see here in the picture here, is able to go and, you know, at least get the sensor feed and be able to move the sensor ball, maybe while a company, you know, with something in a talk with a, you know, a large ground station is actually doing the flying of the asset. Maybe a dismount guy is able to go and just control just pieces of the aircraft. So I believe that is kind of where, as far as our reach will go, within our architecture, but who knows?
Yeah, I can see the wisdom in that, and having the guy in the back flying the MUAS, and then just being able to hand off the sensor to that operator on the front. Yeah, I definitely agree with that. Another question is, do you think the KMX could be possible as far as being able to decipher the various autopilots? For example, it's reading IMUs, which is what ScanEagle uses, and then could you guys pipe it down to an autopilot that you guys designed or somebody else designed?
So, the way the architecture kind of works is, I mean, there are some assumptions that the vehicle itself is doing the kind of low level autonomy and stabilization. So like it's running the high bandwidth control loops that are keeping the aircraft stable, dealing with, even down to like, shouldn't say that, like, roll stabilization, pitch stabilization, throttle and altitude holds, and these kinds of functions are all dealt with on the aircraft. And then in some cases, they have their own GPS, waypoint driver on the aircraft, in which case we can just upload, based on that mission planner I showed you earlier, just upload waypoints to that, to that autopilot and let it just go and do its own thing. Or in most cases, we actually control all of the velocities of all of the different vehicles on the network at the same time, so that we can coordinate behaviors. Again, there's a ton of stuff here I've glossed over within our architecture, and being I'm gonna nerd out here a little bit, but being a robotic manipulations guy and a kind of a mechanisms guy, we've allowed our system to, we're treating our all of the vehicles in the system essentially as a closed kinematic chain, and meaning that we have the ability to when we command and coordinate everything on the same network, we can do so in a very efficient way using some pretty rudimentally basic linear algebra techniques to handle these multi-dimensional degree of freedom systems, and to do that in a very coordinated fashion. And so the result of that is using these assumptions that I mentioned, we can go and make multiple different air assets that have different capabilities, find the commonality in their capabilities, and then make all of them achieve a common goal, go to a place at a set time, at a common time, or tie those to different ground assets. So for instance, our system has the ability to go and say, hey, you could task this aerial vehicle to follow this particular person in that's on your network, on your ATAC network, and provide this kind of overwatch. And so if that person gets in a vehicle, or if that person runs or he stops or whatever, it's going to take all that in and keep up based on the dynamics of the vehicle's capabilities, as well as relative motion of the thing it's trying to track, and that's scalable across any of the different vehicles in and on the network.
So you're interfacing with the native controller to tell it, go to this place in 3-dimensional space and hold or ramp up to this this velocity, this airspeed, or this ground speed.
So yeah, and by controller, just to make sure I'm clear here, obviously not the remote controller that the human is holding, but the autopilot system or stabilization system is in the aircraft.
Right, I got you.
And it integrates either just through plain velocities, hey, go here, turn like this or whatever, or a higher level control where, hey, just go here and waypoint landing, then go and it'll just achieve that. So it depends on the application, I guess, is the right answer.
Okay, thank you.
Yep.
All right, Jason.
Hey, Scott. Hey,
Yep.
Hey, class. Thanks for the presentation. This thing's awesome. So I had a question for kind of along the lines of what Shelly was asking earlier. The interoperability with Link and other radios, does this have the ability to pull anything out of Link to your system for the user, like say an Overwatch Blackhawk or something like that has sensor posture set? Can they pull in that feed as well?
Yep. And again, the Android itself and some of the video clients within Android have limited capabilities as far as what codec they work with, but KXM runs a full-blown version of Linux with all kinds of hardware acceleration for most of those codecs. And so oftentimes that, as I mentioned before, kind of acts as the adjudicator of, we'll say, uncommon video feed, and then turns it into a common video feed that will both work with the end user device as well as others on the network. So yeah, like the use case that you described would definitely, be possible, assuming that, the KXM has a way to, or straight into Android, either one of those can view the video type. Most videos that we're finding are, H.264 or MPEG-2 TS. There's probably 4 or 5 really, but every once in a while there'll be something uncommon or like non-standard that the manufacturer will do with that video that Android is not able to handle, or some of the video clients that are available that we work with, we either have to go in and like tweak stuff at the byte level down to get that video, but more times than not we can solve it much easier in Linux on the KXM and transform it into uniform video after out of there.
That's awesome. So
Yeah.
with this system, is that something that you can you pipe that up to the manned aircraft, or do they have to have your system on board? Like, can you?
No, we can turn it right back around. No, we've done stuff like that. And sometimes these links are asymmetric, right? So you have a better down feed than you will up feed. So in like Satcom, for instance, is a good example. We'll take that video and then transform it, re-encode it, recompress it, and then push it back up over the smaller pipe, so that it will make it back to a talk or back it up to up to an aircraft or what have you.
Okay, that's awesome. And then I have one last question, if you don't mind,
Sure.
real quick. So obviously,
No problem.
talking about being in all these different links and all the different networks that you're putting into, I'm assuming that you're encrypted end to end, correct?
So yeah, yes, it is definitely the answer. It depends too on like, depending upon how the data needs to get, data that we're creating and goes across the network to our other applications, end to end with our own, encryption through, our networking stack. If a system that we're purely acting as a bridge to, for instance, we'll just, pass that along, and that may already be in the encrypted space. We don't have a need to decrypt it, then it'll just kind of get passed along. So, everybody's, use case is different. And so that's one thing we've learned in the last 4 years is we've kind of had to become experts at everything, in the stack, from the waveform down to the application layer and everything in between, to make sure we can get the data in the right way. We're not compromising security, and all the things in between.
All right, that's awesome. That answers the question. Thank you.
Yep.
Excellent. Lawrence?
Hey, thanks for that presentation, Scott. I just had one question about the user interface. Nowadays technology can be very complex, but it's also very important that the end user is can use it effectively with that UI being very intuitive. Mm-hmm. And as you add more features, there is always that risk of UI overload.
Yep.
How do you guys get after adding effective features while maintaining that UI intuitiveness?
That's a fantastic question. And, I think it really goes to the like, hey, anything operational can't be more than 2 clicks away. There's this kind of the fundamental rule that we set, and then and adhere to. I guess that's number one. Number two, certainly we design everything spacing in mind for gloved system, gloved hands and stuff. But things like that, they're very common. I mean, we set a common set of requirements for human factors that we follow from a UI design perspective. But frankly, there's nothing that you can do that's going to be any better than just we'll go up to our customers and say, hey, here's what we're thinking of this. Can your guys play with it for a week and give us some feedback? There's just there's all kinds of things that comes up because of that we've gotten feedback on, and we take it to heart and feed that back in, and then kind of replay. So we have several units that are kind of on a continuous beta, if you will, other universities that are kind of on our beta system with us that are and we continually give updates to get feedback on, as well as kind of end users. So yeah, I don't know, very, very practical approach, I'd say.
Okay, thanks.
Yep.
Then James.
Hello, and thank you for the presentation. Very interesting. Just a couple quick questions. Just want to know what what's the farthest range you've ever got on this thing? And then kind of, does it have GPS so you and the whatever UAV are controlling know where you're at? And does there any sort of anti-jamming or stuff for GPS denied locations?
Sure. Yeah, I think I got 3 questions out of that, so I'll see if I can remember the order here. So as far as we can go, all great questions, by the way. You know, depends on the radio that's in them. You know, we've gone with some ground robot applications using the Persistent Systems radio on lower C-band. I personally operated vehicles out to about 3.5 kilometers. You know, aerial vehicles with, you know, micro hard radios, which is what kind of like the common kind of 4-pound or less vehicles use. You know, we're getting, you know, 3 to 4 kilometers, something like that. As far as GPS, yes, I mean, all the vehicles have, you know, GPS of some variety, whether it's, you know, military grade or just kind of commercial grade. And then, you know, on the kit, you know, most of the time, just the phone's GPS is acceptable for their position. We do have, you know, the ability to, if someone were to plug in a military grade GPS, the KXM, kind of push that NEMA stream up to the user interface so that it can have that better quality, better precision GPS, and then also that kind of provide some anti-jamming functionality and capabilities from the actual, you know, GPS itself. So, you know, we don't make the hardware that, you know, helps with that. We just integrate with it. As far as, you know, GPS denied navigation, some of the stuff that we are, you know, to go a little bit against what I was saying before about, you know, on the researchy side, you know, we are working with some other collaborators and industry partners to basically go out and, you know, we can fly a vehicle out. It can create, you know, taking real-time video, create a 3D digital twin, and then, you know, being able to, you know, create, you know, this 3D map, this digital twin of the environment it just saw, and then go out and then, you know, because the video is coming through that processor, and we're getting that real-time video feed, it can localize itself within the world based on what it's seeing in these common features within the world and know relative location to the world that it just went and found. And so by that, being able to navigate through the world without having to use and rely on GPS, but it's all through, you know, purely relative means. It's certainly not a capability we're deploying today, but just to give you a kind of a feel of some of the, we'll say a little bit more of the researchy side of things that we are working on, but in a very practical way to achieve that. We know that that's going to be a problem for the next fight is GPS jamming and GPS denied, you know, areas. But it is very interesting that, you know, since we are getting all those video feeds and being able to, you know, and have this processor at the edge, we can do those kinds of things in a common way that now we don't have to make that capability available on the drone, on the unmanned system that is likely, you know, not, they expect, you know, it's supposed to be put in harm's way, right? It may not come back. And so why put all the expense out on the thing that may not come back, you know, do it, you know, on soldier.
Thank you.
Yep.
Jason, you have another question?
Yeah, so we were talking about the different operators taking control of the systems. And so one of the questions that I thought you might have touched on this a little bit, but is there a hierarchy for who takes control or how to take control of the system as an end user?
Oh, great question. And, you know, we've struggled with that a little bit, not from a technical perspective, but from like every user group has a different opinion. And, you know, right now we just is first come, first serve, purely to show that the capability is possible. We're frankly waiting for a requirement set from one of the users to say, like, this is how we want that done. You know, right now it seems like the way that everything is going, I can share with you that it will probably be something around like a role-based type, you know, hierarchy where, hey, there's company command, there's, you know, squad leader, you know, assistant squad leader down to, you know, just guy on the fire team. And depending upon the assign-in, we'll preempt a particular operator. We also have, you know, something that we have or that we're planning for is, you know, hey, if, and that will come through a basically we'll still ask for a question response. I think that like the highest level will be able to just take it, but everybody in between will have a request system basically. And if multiple requests comes in, then basically somebody at a different level, that request will just kind of get ignored and bounce back. And the request from a higher echelon person will get through. And I think the paradigm right now is that we're planning on is, look, if the operator of the vehicle like ignores 3 of those requests, then it automatically gives control of the person asking for it, probably because potentially the guy is occupied in something else and not able to do it, and therefore he's probably not caring about the assets that he's got, that he's got control of, or potentially he's down, and the guy in the squad or other people in company need to be able to get a hold of that asset to recover it or retask it or what have you. So that's, it's certainly not set in stone yet, but that seems to be the direction it's going.
Awesome, Scott. That answered my next question too, which was going to be what happens when that user that's in control doesn't have control anymore. So that's awesome. Thank you.
Yeah, you got it.
All right, Nolan.
Hey, Scott, thanks for coming out and doing this. This is all really interesting, exciting. Need to see all these things. I have 2 questions. So it seems like you mostly focus on like software, and there's some hardware aspects. Do you ever plan on getting into building unmanned systems as another aspect of the company? Or
yeah, it's a great question. And coming into this business space, one thing we did, that we recognize is that there's a lot of companies out there making great hardware that have put millions and millions of dollars into making that hardware, and their focus was on just that. And so certainly for now it's been very much a like, let's we want to kind of create this force multiplying capability by allowing users to be able to operate all these systems together at the same time from a common operating picture. So that's been our focus. Much like when we started this business, we are purely software. We set out with the goals of being 100% software, and then we quickly realized like, yeah, great, but the hardware that's available to these guys is also trash. So like we just took it on ourselves, and we recruited more people, and brought mechanical and more electrical and mechanical engineering in to make this hardware to kind of round out this soldier-born capability set and architecture that could grow with new unmanned system capabilities. And so today I say no. In time, maybe I'll leave that carrot out there, because I certainly see holes in capability sets and reliability, and just, I don't know, I would say good engineering that's being left by the wayside with some of these systems. So maybe in the future, we'll say that.
Okay, awesome. And then I have another question too, if you got a sec. As far as the simulation environment, first of all, like those pictures, I thought those were real. A couple of them. One of them kind of looked like Uncanny Valley-like, but I didn't really notice it till you mentioned that they're all 3D rendered. But is there plans to integrate that 3D scanning technology to have people maybe train in real world environments, but still simulated, so they can protect the hardware that they use?
Yeah, I mean that's and if I think I understood it right, the idea, I mean that digital twin that I mentioned earlier, being able to bring that back into the simulation environment is a very near-term goal of ours, so that you could have a scenario where somebody goes out, let's say a week before, maybe a few days before, and they go and they fly, they create this 3D map, and then they create this with this 3D map. They can bring it back into the simulation environment, and then from there do ahead of time tasking or mission planning of the pretty darn close to most recent view of the world, instead of relying on satellite imagery or stuff like that could be months or years old depending on what it is. So yes, that's very much what is on a roadmap and what we're working to achieve today, to give users that capability. And I think that's what you're asking. If I'm wrong, Nolan, certainly ask it again.
Nope, that is exactly what I was asking. It's perfect.
Yeah, and Unreal Engine, and I guess to tag on to Brent's question about technology that it's come about. The shift in Unreal and Epic's approach to Unreal Engine and how they license it even is a big change for us. It's all essentially, it's all open source. and available to us. They have some packages now that allows to bring in that 3D mesh into Unreal to kind of create that digital twin in that mapping environment pretty easy. And so we've we looked at we're utilizing that.
So a slight twist to Nolan's question, are you guys looking at all at augmented reality, where you would have the actual operational hardware, say for the control set, and then you'd have something like Microsoft HoloLens or some sort of viewing device where you could be in the actual functional operational environment, but the uncrewed or unmanned robotic system like the the UAS or the ground robot, Boston Dynamics, Big Dog, something like that, that's simulated so that they could practice operation within the contextual environment. Is that something?
Yeah, that's interesting question. I mean, frankly, we have not looked at augmented reality in that way. Interesting. We have looked at it, very much on the, HoloLens, for instance, and, Microsoft is one of the program called IVAS, where it's basically a, HoloLens 2 or whatever, a little bit more ruggedized, and they're going out and they're basically putting, ATEC-like features out in front of the, users as far as like, hey, go over here, and, very operational centric cues and such in the face of a guy. Using HoloLens or other devices like it to put up, video feeds of vehicles, of unmanned systems that are on the network, so they can view those before maybe if somebody hits a building or something like that. And also, using it to show, let's say there's an asset out beyond visual line of sight that's kind of up in the sky, being able to put some kind of diamond up there to say, hey, you do, just so there's this asset up over here that that's available, and then you could kind of click on that, virtually click on that device to go pull its video stream down, things like that. We've kind of, I would say, experimented more with it. Just it hasn't made it mainstream, certainly in the battle space yet. It's very much in an experimental phase, and so we're kind of going along as well in that kind of experimental phase.
Excellent. Well, with that, I think our last question is from Jonathan, so I will turn it over to him.
Hey, sir. First and foremost, thank you for doing this presentation. Pretty cool stuff. So just my question is a little bit more on the tactical side. Let's say a team of operators, right, is using one of these micro UASs to take a closer look at any structure or target set, if we might call it that, and then if they lose command link with this micro UAS, is there any lost link logic built into any of these platforms so it can remove itself from where it's positioned at the time, and pretty much, like, let's say, continue to remain PID on whatever target set they were previously looking at?
Yeah, and a lot of them do have that capability, and through our configuration screen and menus and such, you can kind of go and set that up so that, yeah, to your point, if you do lose link and you want it to stay on target, because let's say you tell it to start recording and then just go out to this location and come back, or in the future fight, go calm silent and just go and record stuff and come back, kind of thing. Yeah, we don't want to inhibit that capability, so we pass on those parameters and those settings to the vehicle. Obviously, if we're out of communication with it, then we can't tell it to do anything or change anything about it other than what's been preloaded. But I mean, to answer your question, yeah, I mean, we do interface with those kind of capabilities if it exists already on the native hardware.
Awesome, thank you.
Well, outstanding. First off, I want to thank Scott, our guest, for coming and speaking to us about the impressive system that Tomahawk Robotics has created. I also want to thank each of you, the UNSY 501 students, for joining us. Remember to receive credit for participating this week. You need to develop a brief overview for assignment 3.2. That should address a couple things. First, how our guest organization uses or has developed unmanned system technology, just real high level. Two, how lessons learned and or observations that were made by our guests can help advance the field and improve capability. And then three, any new information you were not previously familiar with, including how your overall understanding of the topic has improved. Since this is our first time together, I'm happy to stay on and chat if any of you have any brief questions, or if you just want to pick my brain. And with that, I just want to say thank you again to SBowman for joining us tonight.
Thanks a lot, Brent, and all your students for, listening to me blab here for an hour. I will say that, Tomahawk is growing. I mean, I have the 4 years, so I'm going to use it. Some great questions. It sounds like your students are very aligned with the kind of problem sets that exist, within the unmanned space, especially in defense. I certainly encourage you guys to go take a look at our website. We're looking for engineering and all different kinds of skill sets that I think a lot of you would probably have a background for. So invite you to take a look at there and, come by and see me and love to chat more on that topic.
Excellent. Well, if anybody has any questions, like I said, just stay on, and happy to chat for a bit.
And Brent, did you want me to stay with you, or did you want me to? Is this my cue?
Oh yeah, no, we can catch up later, and I definitely,
Okay.
if you're open to it, I wouldn't mind having a conversation at AVSI if we get a chance.
Yeah, I'd love to. Yeah, that'd be great. I know when
to
your
catch
students
up.
here, Michael Leo's reaching out to me as well here in the chat, and I'm planning to be over there a partial day. I have some meetings lined up there, but I'll try to make a whole day, and Brent, let's make sure to get on each other's calendar, and I'll make sure to make some time to chat.
Excellent. Yeah, and real quick, are you guys going to ITSIC? Because you have the modeling and sim connections, so I didn't know if that's on your radar.
We're not really as big into like the pure simulation side. Yeah, we have the capability. We have some developers that are working on that, but we really haven't, I would say, done as good of a job tracking the state of the art, we'll say, in sim. Just making sure we have a kind of operational product that that the users can train with.
So if you're ever interested in maybe doing some T&E on your stuff and writing a paper on that front, I'll hit you up. I'm more than happy to. And I've got some background with ITSIC and publications over there.
Okay. Yeah, that could be great. Also just in general, and we'll have to talk about this all offline more, Brent, but, I've connected with like UCF and Carnegie Mellon and some other universities, trying to, in some of the student labs and student projects, like I mentioned that SDK, we're also looking to try to have people start to, kind of work behind that SDK to give us feedback there. Right today, the SDK doesn't provide as much capability, in totality as our, inherent system. And we're kind of trying to catch that product up. But, certainly we, see customers that are on the bleeding edge of new vehicles, they love it because they're able to just focus on the vehicle and that, at the very, very edge capability, and not worry about like, hey, a common operating picture and software on and learning Android and all that. They can just focus on, again, the platform, and knowing they have this kind of, great UI and system they can fall back on, just focusing their time, effort, and money on the platform. So if there's any, projects like that and stuff, I would, love to talk to you about that and maybe collaboration there.
Definitely. Outstanding. Well,
okay.
Thank you again.
Yep, you got it. Okay, guys, take care. Don't stay up too late.
Have a great night.
It's late. Yeah, see you guys.